This is part 2 of the Chapter 6 Unit 3B test review. We're on number 8. Number 8 says, if 10 is less than or equal to x is less than or equal to 50, which in something called interval notation looks like this. We want to know what values of h will be true for these x values. It's actually a very simple problem, even though you didn't see one like it in the homework. What you're going to do first is, if your gut is telling you to add 6 to both sides, that's what my gut's telling me to do, so I'm going to do that first. And then my gut is telling me to square both sides to get rid of the radical. So I'm going to get x minus h is equal to 25. So now to figure out what values of h will make this true, I'm going to plug in 10 for x, that's the low end of the interval, and solve that equation for h. So I'm going to subtract 10. And that minus sign in front of the h is like a -1, so I'm going to divide by -1. So I'm going to find out that h could be as low as -15. And then I'm going to plug in 50 for x and find out what my high end is. I'm going to subtract 50. Maybe that isn't my line. Let's see. -20. Oh. And then I'm going to divide by -1. I'm going to 25. So it's going to turn out, that I want h to be between -15 and 25 in order for this equation to be true for x values between 10 and 50. So all I had to do was start the problem off like I normally do. Isolate the radical, get rid of the radical, and then I went to this interval and I plugged in the low end for x and I plugged in the high end for x, and that gave me my interval of h values. In problem 9, it says a salesperson earns a 3.5% bonus on weekly sales over $5,500. Considering the following functions. G of x is equal to 0.035x. That's the equation that represents the 3.5% bonus, because 3.5% as a decimal is 0.035. We move the decimal 2 places to the left. And h of x is equal to x minus 5,500. That's that sales minus the 5,500, because you have to be over that in order to get the bonus. So when it says write a composite function, it didn't tell me which direction. So for the sake of argument, I'm going to write both. So one direction could be g of h. Remember, that's pronounced g of h. That means plug h into g. That means wherever I see an x in g, I'm going to replace it with the other function. Now you should be looking at this going, oh, I want to distribute, so I'm going to get 0.035x minus 192.50 is what you get when you multiply 5,500 times 0.035. Then the other direction, what if instead I did h of g? That means I plug g into h. Well, if that's the case, then I'm going to take this and plug it in here. So I'm going to get 0.035x and then minus 5,500. You'll notice that the equations are not necessarily the same. When you do function notation, the direction in which you do the composition matters. Now my next question is, which direction actually works? Well, let's do this. Let's pretend that your sales are 7,000. Why did I pick 7,000? Because in order to get the bonus, your sales have to be over $5,500, so I picked a number over 5,500. So let's say that x is 7,000. So those are your sales. So now let's find out what your bonus is going to be. So if you use the red function and you do 0.035 times 7,000 minus 192.50, you're going to find out that your bonus is $52.50. Not a high bonus, but it's a bonus. If you instead use the purple function and you do 0.035 times 7,000 and you subtract from it 5,500, you're going to find out that your bonus is negative $5,255. Oh, really? You owe them money back? I think not. So what that ends up telling me is that this is the only composition that actually works. So even though you can do the composition both directions, it turns out that the red one actually works. It's going to tell you what your bonus is. The purple one says you owe them money. You don't owe your company money. In problem number 10, it says, consider the following functions. F of x is equal to 7x plus 5, and g of x is equal to x squared. We want to determine which answer is true. The reason that there is a problem on the test formatted in this way is because there were problems on the PARCC tests that were also like this. So, for number 1, Roman numeral 1, g minus f, that means take g and subtract from it f. Because operations on functions are really just operations on polynomials, you got to distribute that negative. So it's going to be x squared minus 7x minus 5, which must be a. All right, for Roman numeral 2, we're going to multiply g times f. So g times f. But wait a second, I want you to notice that neither of those answers are multiplied out. How do I figure out which one's true then if neither of them looks like this? Well, really, this looks like it, because one of the things we know about multiplication is that it's commutative. The order in which you multiply doesn't matter. You'll get the same answer. Now, for Roman numeral 3, they ask us to do a composition on functions. They want us, remember, it's the second function gets plugged into the first one. So g of f says take this and plug it into that. When I do that, I'm going to get 7x plus 5 squared, which is clearly not 7x squared plus 5, because whenever you square something, you have to write it twice, and then you've got to FOIL it. So you would get 49x squared, and right away you're going to know that's the answer, plus 35x, plus 35x, plus 25. The two terms in the middle are like terms, and they add up to be 70x. And that's how I know A is the true solution. In problem number 11, suppose the function f of x is equal to 0.15x represents the number of US dollars equivalent to x Chinese yuan, I guess it's pronounced, and I just wrote this backwards, didn't I? Because x is the Chinese yuan. Can't even spell it, to US dollars. And then the function g of y is equal to 10.49y represents the number of Mexican pesos equivalent to y US dollars. Write a composite function that represents the number of Mexican pesos equivalent to x Chinese yuan. In order to do this, we're going to do a composition of functions. And because there is no plus or minus signs going on, it actually doesn't, the order in which you do your composition doesn't actually matter. However, since the problem says that it wants to do the number of Mexican pesos equivalent to x Chinese yuan, we want to have x still in the equation. So we're going to take this and plug it in here for y. So it's going to be 10.49 times 0.15x. And then you just multiply the 10.49 times 0.15. 10.49 times 0.15 is 1.5735. So 1.5735x is going to be the equation that will give us the Mexican pesos equivalent to x Chinese yuan. The reason this didn't matter, the order in which you did the composition, I want you to look what happens if I had gone the other way around. If instead I had done this, I would have gotten 0.15 times 10.49y. 10.49 times 0.15 is still going to give you 1.5735. It's just a matter of which variable was in the problem. And since it said X Chinese yuan, I wanted to have X in the problem. In problem 12, it says let f of x equal to x squared minus 4, and g of x is equal to the square root of x. What is the solution of g over f of x and the domain of the result? The domain of one of the original functions does transfer over to the domain of any operations you perform on functions. So let's look at the domain of each of the original problems to start off. F of x equals x squared minus 4. That domain is all real numbers. There's nothing that's going to give you an error message. However, g of x equals the square root of x. When you have square roots, x has to be greater than or equal to 0. Because if x is less than 0, you have a negative under a square root sign and you don't get a real number. That domain is going to transfer over to the new domain. Now, for the new domain, when you write these division problems, I told you that you need to worry about values that make the denominator 0. But because there was a domain restriction on the square root of x, that will be part of my new domain. So x will still be greater than or equal to 0. But we're also going to deal with the denominator. The denominator cannot be 0. So any numbers that make the denominator 0 don't work. Well, since this is an equation, and I'm solving an equation, and this only works when you solve equations, and you take the square root of both sides, you're going to find out that x is plus or minus 2. It's not equal to plus or minus 2. But I want you to notice that negative 2 is already not in the initial restriction on the domain, because the numerator has to be greater than or equal to 0. So negative 2 isn't bigger than 0. So the other thing is that x cannot equal 2. So x has to be bigger than 0, and it can't be 2. But every other number bigger than 0, but not 2, will work. And that's the domain. In problem 13, they want us to find the domain and range of the inverse of the function y equals square root of x minus 5. What I'm going to do is I'm going to start by graphing this and then go find its inverse. Now, the graph of the square root of x minus 5 is the graph of y equals square root of x that's been moved to the right 5. So if the original graph goes through 0, 0, 1, 1, 4, 2, 5, 6, 7, 8, 9, 3, then when I move that 5 units to the right, I get 1, 2, 3, 4. It starts here. 1, 2, 3, 4, 5, and then it's here. 1, 2, 3, 4, 5, and then it's here. 1, 2, 3, 4, 5, and then it's here. And if you don't know where the graph is, remember you can just put it into your calculator and find the first couple of ordered pairs. You don't even need that many. So this is the original graph. It goes through 5, 0, 6, 1, 7, 8, 9, 2, 10, 11, 12, 13, 14, 3. So the inverse is going to go through 0, 5, 1, 6, 2, 9. I'm going to run out of space here, so I'm just going to do this. There's the graph of the inverse. Now the equation of the inverse you get by flip-flopping x and y, and then solving the equation for y. So this is the equation of the inverse. Now I want you to notice that the inverse of a radical equation is going to be a quadratic equation. But it's not quite a parabola, is it? It's only a half a parabola. That's because the original graph was like a sideways half of a parabola. So the domain now, I want you to notice that x is greater than or equal to 0. because the other side of the graph is not there. The range, the y values are greater than or equal to 5, because the y values start at 5 and then they go up from there. The x values start at x is 0 and go right from there, and that's your domain and range of the inverse, and this is the equation of the inverse. In problem 14, we want to know what the inverse of the function y equals 4 times the quantity x minus 2 is. You have a couple ways of going about doing this. If it makes you feel better to distribute it and then find the inverse, that works. To find the inverse, you flip-flop x and y, and then you solve the equation for y. So we're going to add 8, and then we're going to divide by 4. And although I'm okay with this answer, sometimes in multiple choice answers, they might separate it like this, in which case the answer would be 1/4 x plus 2. I will accept this answer on a non-multiple choice test, so it's not that big of a deal. In number 15, they want to know what the inverse of this relation is. The inverse of this relation is really easy. Now, the ordered pairs here, even though it's written as a table, these are the ordered pairs, right? In an inverse, all you have to do is flip-flop x and y. So the ordered pairs of the inverse are going to be 3, negative 5, negative 6, 7, 3, 11, negative 8, negative 18, and negative 9, 4. And when I mean flip them, I mean flip them. They don't change signs. They don't go from positive to negative, nothing like that. You literally just flip the numbers. In problem number 16, it says a high school principal uses the formula y equals 60 times the quantity 2x plus 3 to predict a student's score on the math portion of the SAT using a student's 11th grade GPA number as x. Using the inverse, what GPA does a student need to achieve to get a score of 730 or better on the math portion of the SAT, and what is the equation of the inverse? Now, to do this problem, you don't actually have to find the inverse, but we're going to do it anyway because that is part of the question. So again, it might help you if you distribute it first and then flip x and y and solve for y. So I would subtract 180, and then I would divide by 120. And you can leave the answer like this. Or if you want to do this, you can, and you can reduce this fraction. You got to think for a second what it would be. 3 over 2, I guess it would be. So it would be x over 120 minus 3 over 2. Either equation's fine, but I will take that one. Then, not only do they want to know the inverse, but they also want to know what you would need, what GPA would you need in order to get a score of 730 or better. The thing about the inverse is that now you can plug the 730 into the inverse in order to find your GPA. Because in the original problem, this was your GPA, and this was your SAT score. In the inverse, this is the input becomes your SAT score, and the output becomes your GPA. So if we know you want to get a 730 on the math part, we need to find your GPA. So 730 minus 180 is 550. And then 550 divided by 120 is going to be a 4.58, which is really, that must be in an honors scale, I would suspect, because normally GPAs are out of 4. You could have found the same answer by doing the problem up here. You could have done 730 is equal to 60, 2x plus 3, in which case I would have first divided by 60, and I would have gotten about 12.17. and then I would have subtracted 3, and then I would have divided by 2, and I still would have found out that it was about 4.58. I don't have an example of the performance assessment test. There were 3 of them. I'm only actually going to give you one of the 3 of them, but I will tell you this about the performance assessment task. You need to know the Pythagorean Theorem. I can't even spell it right. Pythagorean Theorem. The problem has to do with a right triangle and finding one of the sides of a right triangle. As long as you know this, and as long as you know that C is the hypotenuse, you will be fine. So again, for the performance assessment task on this particular test, all you need to know is the Pythagorean Theorem, and you will be able to find the right answer.